Hey everyone, and welcome to this week's episode of BSD Synergy. This week will be part 2 of our series called SSH. It can do that. First off, I want to welcome everybody to the show. If you're new to the show, welcome, and if you're a vet, welcome back. So this week's introductory section is going to be a lot shorter because I've already really gone over what SSH is and where it came from. So I'm going to kind of show you something nifty that I found that may completely bore you, and if it does, skip ahead, but I think it's really cool. Since we're going to be talking about key authentication today and some sort of levels of encryption, I wanted to show you some things that I found while I was on vacation in Colorado. So this thing is a baby Enigma encryption machine. So you can spin the wheels. This is your output wheel right here, and you spin them and you get what, I want the letter Q, and I read over here and it's E, and these are interchangeable, and you change them and you can change your encryption level. Now this is what's known as the Enigma 2, and this is the baby level. This is the introductory level. Not really many key combinations here, relatively easy to crack, but if you've always been interested in how the Enigma encryptions work and you just kind of want to play around with it, I paid like $30 for this. This is pretty cool. I got one for my little brother, and he and I send little encrypted messages to each other now and then, just for fun, not because out of necessity to try to hide things, but because why not? It's pretty cool. But this is the Enigma 2. Now, they do go up from the 2 up until the big 5. The 3 basically takes this same model and makes the disks reversible. The 4 adds 3 more disks, so you have basically 6 disks. It's still a 3-wheel, maybe this is even a 2-wheel Enigma machine, yeah. The 2-wheel Enigma. So it's it's a really weak encryption. But if you want, and you want to spend like $80 like I did, you can get the Enigma 5, which this one is actually a 37 spoke instead of the other one, which is 26. This has alphanumeric and a period. They're interchangeable disks. And you change it. There's 10 disks, and you have your output, and you read across and then down, and then you keep alternating back and forth between it. And there are, according to the paper, there are 7.2 billion key combinations with this Enigma machine, and there's even a little challenge. If you can find on the website of the guy who sells these, there's like 6 encrypted messages, and if you can break those messages, you get, I think, $150, and you get to set the messages for the next person to break with this Enigma machine. So these are pretty nifty. I paid $80 for this, and I was really, really excited to find it, because it's hard wood, and it's like, really finely laser engraved, and just, really cool little toy. Nice little thing. If you're interested in encryption and in cryptography like I am, then I think you'll really enjoy it. But anyways, let's go ahead and just get on into the demo this week. Okay, so I currently have 2 SSH servers. I have SSH server and then SSH client. They're both cloud servers I use on DigitalOcean just for the point of this video, but it's nice to have fresh environments that I don't have to worry about. So the first thing we're going to talk about is passphrases, passwords, and key authentication. So, as you know, password stealing happens all the time. Now, the likelihood of somebody getting in and stealing your Unix password off of your server is, it's about as secure as your server is. You really don't have to worry about it too much, but, through other weird things, man-in-the-middle attacks, or, you just having a really weak password. Most of the time, brute force is the cause of these. Passwords are really not good to use for server authentication. I personally don't use any password auth anymore unless I absolutely have to, and if I absolutely have to, I usually reevaluate why I need that. So, we can do something called key authentication, where basically we create a public and a private key, and these 2 keys unlock each other. And then we would put the public key onto our server, and then whenever we want to log in, we present our private key to it, and it unlocks it, and we're allowed in. And now, I'm pretty sure the algorithm in which we do this is much more complex than I just made it out to be. I know there's a lot of stuff that goes on in the background. I'm just trying to keep this at a basic level, because even I don't really understand all of the layers of it. Haven't really ever looked into it, but I trust it. And like most people do, most people trust SSH. It's one of the few things that I found that across the board, nobody goes, oh, OpenSSH, that's not secure. I've never heard that in my life. Okay, so we're going to go ahead and show you how to create a key on your client and add it over to your server, so that way you can authenticate directly to your server without needing a password. So the command to do this is ssh-keygen And then you have to give it a couple of flags. -T stands for type. There are 3 main types that SSH supports. There is the RSA, DSA, and ECDSA. I personally use RSA as the default, and I believe OpenSSH defaults to RSA if you don't specify it. But I'm going to go ahead and specify RSA. You do -B for the number of bytes. Now, the more bytes you have in your key, the technically more strong your key is. You know, using a key of only a couple of bytes would be catastrophic. It'd be really easy to guess. But using a key of, say, like even 1024 bytes, well, technically a strong key, yeah, really not too terribly strong. I personally do keys of 4096. I'll probably increase that number later on at some point. Just know that the more bytes you use, the more cryptographically hard it is on the hardware to use these keys. So you do get that trade-off. I've really never seen any downside to using a larger key. I've never seen, like, it doesn't take me hours to log in. I don't know. I don't know at what point your key becomes too big, or if it even at that point does it become redundant. I'm not a cryptologist, so I really couldn't tell you. But I always use 4096. That's just my personal preference. And then -C, you put an email address in there. It's just a nice way of being able to identify the key at the end, what key it is. So I usually do, we'll just do mason@bsdsynergy.com. Okay, so it asks where you want to save your key, which this is the default location. That's where I'm going to save it. You can save it in other places, but this is typically where I save it. Passphrase. This is where we were going over passphrases. Passphrases are much longer than passwords. The private key you should guard with your life, and if you have a weak passphrase or somebody gets a hold of the private key and it doesn't even have a passphrase, then they can be you. They have your identity. They can willy-nilly get into everything that you have used this key for, and that's really bad. So I usually have pretty strong passphrases, and you should too. And we're not talking things like, 16 characters. I'm talking like the passphrase I'm going to use right now are, these are the voyages of the Star Trek Enterprise. Now, technically that passphrase is still kind of weak because it's from popular culture. However, if you throw in a couple of random letters, some, leet speak, basically lead it up, it should be fine. Or you can, just a couple of random words. Correct horse battery staple, like from the wonderful people at XKCD. So random gibberish like that. The longer, the better. Password complexity, there's a lot of things that go into it. And there's a wonderful XKCD comic on it if you want to know. But in reality, length is what matters. So now I have to type that thing again. These are the Damn it. See, the only other bad thing, you get it wrong. These are the voyages of the Star Trek Enterprise. These are the voyages of the Star Trek Enterprise. Got it. Okay. And now you have your key. You have your SH56, your key fingerprint, Mason at BSD Synergy, the random art that was generated to create the file. So now I want to put this file over onto my server so I can log in. So there's 2 ways I can really do this. If I already have access to my server, which I did, I could go into .ssh authorized keys, which currently does exist because I am using DigitalOcean servers and they use authorized keys for that. However, I don't really care for this too much because you either have to copy and paste, and that's just, in its own right. I'm not, maybe you have a key listener, maybe you have something that's capturing the clipboard on your computer. You're just giving away your public key. This is just extreme paranoia. You could type it letter for letter. That's a lot of work. There is actually a tool built in, SSH-copy ID. You do -I for your identity, and I've already changed directories into my .ssh directory. I'm going to do my ID rsa.pub because we're putting our public key over there. And then freebsd and it's just server. If you're wondering how I'm resolving this, Etsy host file. And right now I actually do have a password on for this. That's the only downside, is that if you already don't have key auth, you have to have the password on for just a little bit. Typically I turn on password auth, copy a key over, turn off password auth. Really close together. and I'm restarting the SSH server in the process. So in that brief period of time, they could try to brute force it. They're not going to get lucky because they usually choose much more secure passwords than what I'm doing for this show. It would, to be in all secureness, it would be better. The most secure way I could think, I have physical access to the server, I view it on my computer, and I hand type the key in. That's the most secure way. While arduous, it's not impossible. We take the little bit of risks. I feel like this one's not too terribly bad. Breaking SSH is really hard. And my passwords are not guessable. Sometimes I even choose just do a random password generator, 128 keys. That's what I use in here, and it works. They'd have to be actively watching, and that's not at a level that I'm completely paranoid about. If I was to the level where I thought there was somebody actively in my machine, one, I would wipe my machine and get them out. Two, I would do it through the serial console. So, there's levels of paranoia. Let it fit your level. So for now, passwords, BSD Synergy. You don't have to worry about trying to get into these servers because before I even upload this video, these servers will be gone. It's one of the things I like about cloud services. I use them as I need them and then I wipe them out. So I now have that key over there. So now I can SSH server. Okay, so that actually took quite a while. I've never seen it take that long. Maybe 4096 is a lot when you have a really teeny tiny server. Oh well. So now we have to enter our passphrase. These are the voyages of the Star Trek Enterprise. And there we go. We are now, as you can see, that is basically your public private key authentication. So now what I'm going to do is I'm actually going to, now that I have it on this server, I have a key onto my server. I'm actually going to do it through this SSH session, no less. Sudo into etc sshd config, and I'm going to remove password auth. So password authentication. So I'm going to go ahead and restart the server. Sudo service. So I'm going to go ahead and restart the server. Sudo service sshd restart. And now there'll be no more password auth. Won't be allowed. Okay, so if I actually try to SSH in with another user now, it eventually tells me that it was denied. One thing that I noticed with the DigitalOcean stuff is just setting password auth to no didn't seem to work too well. It still seemed to let this user in. Probably because DigitalOcean might be using some PAM settings or something. PAM it's defaulted on. So I would make sure if you double check, make sure that your stuff actually doesn't allow password auth with another user that has a set password. But setting password authentication to no in every other instance that I've ever dealt with this has always worked. I don't know how these DigitalOcean cloud images are actually made, so could have been a problem. Now, if you do want to actually allow maybe certain users to log in with password, or maybe allow password logins from, say, inside your subnet or something, remember the match Boolean statements that we did last week where you could match address, blank, password auth yes, or match user, BSD send, password auth yes. You can do those things to allow certain users if you want to, but it's just better off not allowing passwords. Okay, so the last thing we're going to cover in this video is going to be forwarding, and we're not going to cover X11 forwarding because, as you can see, the servers don't have X11, so there's really no point in trying to do that this video. So basically, we're going to cover a very important SSH topic known as port forwarding. SSH can actually serve as a wrapper around arbitrary TCP traffic to allow you to cloak services and ports within SSH and it be secure. You can do this for insecure traffic such as HTTP or Telnet or something if you wish to make this traffic work. And it's actually pretty nifty. So there are three types of port forwarding. There's local port forwarding, remote port forwarding, and dynamic port forwarding. I'm going to show you an example of all of them. So we're going to start off with local port forwarding. Local port forwarding redirects a port on the client to one on the server. So basically, this port on my client, whenever I try to hit it, will redirect to a port on the server. This can be used as a kind of way to bypass firewalls. I don't have access to the web server on this remote machine outside of my firewall, but I have access to SSH for some reason, so I can SSH to it, and then I port forward 80 on that machine to my machine, and then when I go to my machine, I can see it. One of the things about port forwarding is while it's an amazing sysadmin tool, it can be used to do, I guess, not nefarious things, but things that would really piss off your IT security administrators. So I'm going to show you how to do these things. If for some reason you decide you want to take them and try them out at work and get around your company's security policy, if you get fired, it's not my fault, and honestly, you kind of deserve to do so. Follow your IT security personnel's policy. They may not be the most liked people in the building, but they are trying to protect the company. So what I'm going to do is I'm actually going to port forward the port 80 on my SSH server, which I've set up as a basic web page, to a local port on my actual machine, on my client machine. So if we do SSH-L, uppercase L, and I can either specify a local IP here, or if I don't, it pretty much knows, hey, don't use, or it uses the local host. So I'm not going to do that. So we're going to say the local port that I'm going to use. And a good thing to know, on Unix systems, all ports below 1024 are reserved. And if you want to actually bind to these ports, you need to be root. If you're doing this on Windows with PuTTY, they don't really have a concept of reserved ports, which brings for some really interesting fun. So you can kind of willy-nilly do whatever you want. I'm going to recommend using high number ports, that aren't going to conflict with anything else. So I'm going to bind 8080, which is honestly, it's a common web developer debug port, I've noticed, to the remote IP, which I believe I can do localhost. And then the remote port is port 80, and it's going to be on server. Darn it, I missed it. Okay, so now I'm actually SSH'd into my server. Now, the only bad thing is that I opened that port on that machine, and now I really can't view it unless I open up another terminal, which I can do. Or I can use the -n-f flags. -n tells don't do anything on the server, and -f runs SSH in the background. So I'm going to go ahead and do that. Okay, so I'm still, as you can see, on my client machine, but on port 8080 there should be the web server port. And actually, yes, there it is. As you can see right there, greetings from the BSD OpenSSH server. If you actually were to go to that server, you would see that. My current, if you don't believe me, CURL localhost, my current web server, because I have them on both, is saying client. So I now go to port 8080 on my machine, and I have port 80 just directly redirected. This will bypass any form of traffic because it's doing it over your SSH connection. I actually don't know what kind of performance hits you will take for this by masking it into another process. That'd be a really interesting thing to know. Again, use this at your discretion. Don't get around your company's firewall. This is one of the reasons why, if a companies will either they will either terminate SSH connections after a certain point in time, or they will just not trust SSH. Lots of things. But yeah, there you go. So that's a local port forward. Now we're going to go into remote port forwarding. A remote port forward basically takes a port on your SSH server and it's forwarded to your client. So this kind of allows you to, again, bypass more security things. So basically, say you have a machine on behind a firewall. So we have this, and we have our firewall. And I want to be able to access this SSH from outside, but I can't. But I do have SSH access out. So what I can do is, and this is really hard to do with only so many, my chin is going to be, I can create an SSH connection from here to here, and then and arbitrary port, let me say 2222. And then when I SSH to the port over here, it will automatically be redirected through that SSH connection back into here, and I have a backdoor. I know some system administrators use this for, just as a absolute last case backdoor. Again, this is not meant to be nefarious stuff. This has legitimate real world purpose. but it can be used in a bad way. So please don't. And if you do, don't blame me. Not my fault. You know, I am not responsible for your job if you decide to piss off your IT security administrator. So the way we do that is basically SSH-R for remote. The remote port that I want now, instead of it being local port on the local port forwarding, it was local IP, local port, remote IP, remote port. On this one, it's the opposite. It's remote IP, remote port, local IP, local port. And as you noticed, I used localhost as my IP. So when I use localhost as my IP in these commands, basically what it means is that only this connection can run. This SSH connection, and it's only running across these localhost networks. So really, it can only happen across this SSH connection. If I put this on a public-facing NIC, then anybody who could actually access that port on that public-facing NIC would have access to it. This could be used if you want to provide other people things. This is the command that we use to port forward. So basically, remote IP address, localhost. Remember, I'm binding this so that only this happens across this SSH connection. Or from this, you know, basically this machine, this connection. If it happened otherwise, anybody be able to listen to it. If it happened off this machine. 8080, that's the port that the stuff is getting forwarded to. Localhost on the client. So this is actually, you know, the client machine, and then 80 is the port that it's getting forwarded, and it's on the server. These are the voyages of the Star Trek Enterprise. If you're curious, I never actually use that. Now we go over to the server, and I localhost 8080, and as you can see, it is talking to the client. I went to port 8080, and it redirected me to the server through my SSH connection. Okay, so to create this SOC server, it's actually pretty easy. SSH-FN, again, we don't want to be seeing stuff. D for dynamic. And then what we do is we just say the local address, localhost, and we're going to do this across 9090 for a change. And then server. So what this will do is this will create a proxy on our machine on port 9090, and basically all traffic will go to the server through the proxy, and it will create dynamic port forwarding for us. Secure through SSH. Okay, so there we go. So now to actually test this, you actually have to use SOCKS 5 for curl, and it's local host :9090, and we're actually going to do we'll do my website, http. No, we won't. I decided against it. We'll do Google. I like dumping lots of crap to my site, to my screen. And that went through the proxy, bounced through, and got it through Google. So, okay, and that's all I have for you this week. I hope you enjoyed it. Hope you learned something. If you like this video, go ahead and give me a like. If you want to come back and see me some more, go ahead and click that subscribe button. It really does help and makes me feel good. Next week, we'll be working on setting up a VPN server through OpenSSH, and I'll give you a hint. Kind of has some stuff to do with that dynamic port forwarding we're working on. So, I hope to see you next week, and have a good week, everybody.